Welcome back to Instrumentation Unlimited channel, where we learn industrial automation concepts into simple, actionable insights. Today, we're diving into a crucial yet often misunderstood topic: when to add input and output chokes in a variable frequency drive, VFD system, and how to calculate their ratings based on cable length and motor power. Stick with me till the end, and you'll leave with clear recommendations to enhance your system's reliability. Picture this. You've just installed a new VFD for your motor and everything runs smoothly. But soon, you notice excessive electrical noise, motor overheating, or even sudden drive trips. Why? Because of harmonics and voltage spikes. This is where chokes come to the rescue. Chokes help by reducing harmonics on the input side and mitigating high-frequency voltage spikes on the output side, protecting both the motor and the drive itself. So, when do we need an input choke? If your VFD is experiencing excessive harmonics, voltage drops, or frequent drive trips due to power quality issues, an input choke is a must. It's especially beneficial when multiple VFDs are connected to a weak power supply network grid, or when the total harmonic distortion, THD, needs to be reduced. So rule of thumb is, add an input choke if your supply impedance is low, or if you have multiple VFDs in parallel on the same power supply source. Recommended choke value is 3% to 5% impedance relative to VFD rating. For example, for a 100 HP or 75 kilowatt VFD running on a 400 V supply, a 3% input choke would have an impedance of around 0.03 x 400 V or 12 V drop at full load. Now let's talk about output chokes. Imagine sending water through a hose. The longer the hose, the more resistance it faces. Similarly, when the cable between the VFD and motor is long, reflected waves and voltage spikes increase, causing insulation damage and motor heating. An output choke dampens these spikes, protecting the motor. When to use output chokes? If the cable length between VFD and motor exceeds 50 meters, 165 feet. If motor insulation class is not rated for PWM voltage spikes. If motor overheating or noise issues are observed. For example, for a 50 kW or 67 HP motor with a cable length of 80 meters, an output choke with 3% impedance will limit voltage spikes and extend motor life. Now, let's break down the math behind choke selection. The impedance of a choke is calculated as impedance, Z. Percentage of impedance x line voltage, full load current. For input, choke, impedance, or 3% of supply voltage, drive current. Example, if VFD operates at 400 V 100A, then ZARF 0.03 x 400 V 100A 0.120. For output choke, typically 1 to 3% impedance is chosen based on the motor power. Example, for a 50 kilowatt motor with an 80 meter cable, a 3% output choke is recommended. To wrap it up, here are the key takeaways. Use input chokes when multiple VFDs are installed or harmonics are a concern. Use output chokes when cable length exceeds 50 meters to protect the motor. Calculate choke rating based on impedance percentage and system parameters. Always check VFD and motor manufacturer recommendations for specific guidance. Understanding when and how to use chokes in your VFD system can make a world of difference in reliability, efficiency, and longevity. If you found this video helpful, make sure to hit the like button, subscribe, and share it with your colleagues and friends. Let's spread the knowledge and keep our systems running smoothly. Thanks for watching, and see you in the next video.